Hello student, yesterday discussed about the various the data transformation technique in the data science with the help of the Panda and NumPy. This we have discussed in the last class, and there are some other data transformation technique. This will discuss today: binning, summarization, standardization, discretization, classing. This will discuss today. Um, Suppose in the same way as we can create the data set, this we have already discussed how can you create the data set, import pandas as pt, import numpy as np. Then the data, we are creating the date column, temperature, humidity, wind speed. 4 columns we have created, and these 4 columns we are creating in a data frame format, right? So what are the other things we can do with the help of the data transformation technique? This I will discuss today, and the outlier also will discuss today. Okay. um, so suppose we have created the data frame. Now there is one function, that is the discrete function. So what it returns? Discrete function provides the statistic about the each and every column. Okay, so if I execute this one, okay, first time execute this one, and if I want to see the value, okay, see the value, then you can see here the date column, the temperature column. So the mean is the temperature mean is 25.5, minimum value is to 29, 25% of the temperature value is the 23, 50%, 75%, and maximum value is 3, and standard deviation is 3. Humidity also is like this way. Humidity, there is a mean value of humidity, maximum value of humidity, standard deviation. So all the statistics value you can see if you use the escape function. Summary of the statistics, this we can see. Binning. Binning is one of the data transformation technique. This is similar to the discretization and the generalization. The discretization, we have used the same thing where discrete the value. Okay, so binning is also same thing only. So just the different name is their concept. So you can see the code, discretization code and the binning code is the same thing. We are giving the boundary. There are the temperature range, continuous temperature values are there. We want to discrete the temperature value in a different categories. Okay, cold, mild, warm, hot, like this way. So whatever values are there, suppose I have temperature value 20 to 30. So I have providing some boundary for categories into the different class. Okay, so 20, 23, 20 to 23, there will be a one range, 23 to 26, 26 to 29, 29 to more than 29. Okay. So this the one cold, 23 to 20 is mild, 26 to 29 warm, and more than 29 will be hot. Okay, so the boundary we are providing, and for each boundary what will be the class you are going to give or category you want to give, you have to store in another list format, and these two lists you have to pass through the cut function. There is a cut function. You have to write the which column you want to go to discretization, this column name you have to write, and there are the two arguments, one is the bins argument, one is the label argument. So you have to pass the boundary values into the bin argument, and the whatever the category you are going to give, this categories you have to pass through the label. Okay, so this is about the binning. So binning is same as the discretization, whatever I discussed in the last class. Classing. Classing is also same thing. You are to classifying the continuous value in a different category. Okay, so but this name are different. So the same code we use when I discuss the generalization. If some continuous value is there, you are noting down in a general format this value. So here also, if temperature is less than 57, we want to divide the humidity range into the low category, 57 to 63, the moderate category, more than 63, the high category. Okay, so these we used to do this thing also. Okay, so this what the continuous humidity values are there. We are classifying the humidity value in the different category. This concept is called the classing. So this is also known as the generalization, right? So we are writing some syntax into the function under the function, and this function I am applying on the particular column. So df humidity, this is the existing column, I am applying the humidity class, I am passing the humidity class function through the apply function. Okay, this apply function I am applying to this humidity column. Okay, so we will get the new values, and which will be stored in the humidity class column. If I see this column, if I want to see the df now, you can see the humidity corresponding to 55 low, 58 moderate, 60 low, 54 is again low. Like this way you can categorize the humidity values. Now come to the standardization. Standardization is also one of the method of the z-score normalization. So normalization, I told that in the last class. So whatever values are there, you want to normalize those value between the 0 to 1. Whatever values are there, you want to change those value from different range to 0 to 1. Okay, for doing it is easy to process those kind of the data. So this normalization is the one of the process for z-score. Okay, uh, then the temperature equal to temperature hyphen temperature mean, the whatever the temperature, the formula is the whatever values are there under the temperature column, this value minus the mean value of the temperature divided by standard deviation of the temperature. So this mean value and standard deviation automatically we can get from the statistics. This is about the statistics. Okay, right. So for temperature also you can standardize, humidity you can standardize, wind speed also you can standardize. So this is the one of the formula for standardizing the or normalizing the different columns. So the corresponding value minus the mean of the the value and the standard deviation of the value. Okay, so temperature, you can see the temperature standardized. If you do, you will get sometimes the negative value also, because you are subtracting the temperature from the mean of the temperature. So these are in the range of the difference. So suppose 1.2 2 to 0 range, like this way these values are. So next is the outlier and the global outlier and the contextual outlier. Can be divided into global outlier and the contextual outlier. Contextual outlier means sometime based on your requirement, there will be some outlier, means you have some data point. When you see the column, at some point you can see this is not relevant with the other values. So suppose the temperature you should get from 20 to 30 degree, but there is a one value under the temperature column, that is 100. So it should not be relevant, right? So this is the global outlier. So any environment temperature will not be 100 degrees. So this is the global outlier. So this is the error mainly. We have to remove the global outlier. We have to replace the 100 with some other value. Okay, mean of the temperature, some other value. This is the global outlier. Contextual outlier means, suppose you are you are going to measure the current for a device. Okay, so current values are like, sometimes due to the physics of the device, due to the phenomenon of the device, the current will be more high for a particular point. This is not a outlier. This is the conceptual. So this is relevant with the physics or with the expert or domain knowledge persons can identify the particular data point is the contextual outlier or the global outlier. Okay, so there are the two kinds of the outlier. Suppose I have created a one data set and various values are there, random values are there for temperature, humidity and speed, and these values are there. Suppose here I have created the data set, but normally in the data set you can see the such kind of the outlier. In the, if you call the CSV file, you can see such kind of the outlier. So if you want to see whether any column, any outliers are available or not, suppose you can use the box plot for a particular column. Suppose if you use the box plot, C1 provide the box plot for a temperature column, you can see two different points are there. One is the 100, one is the -5. So these two are the outliers. So temperature will not be come into the 100 range. So this is the outlier. We have to remove the temperature for particular. Similar to if you plot the box plot for humidity and wind speed, you can see is there any outlier or not. Already I have created the data set like this way, whether the temperature 100 and -5 will be the outlier. For this range 30 is the 20 outlier, over wind speed 50 is the outlier. Okay, so if you plot the box plot, you can identify whether any column any outlier is there or not. You can also remove those outliers with the help of the various mechanism. Okay, so this mechanism I am not going to discuss, just what I mean with the outlier, this I have discussed. So in a column, if we some range are there, if we see the one range which is not relevant to the other values, that is called the outlier. There will be two types, one is a global outlier, one is a conceptual outlier. Global outlier you can remove easily, or you can replace with the existing value. Conceptual outlier, we cannot remove easily, you have to think before removing the before modifying the value, right? So I hope you like my video, or if you have any comment, you can write on the comment section. Please like, share and subscribe my channel.